Network Automation Nerds podcast. Hello and welcome to Network Automation Nerds podcast, a podcast about network automation, network engineering, Python, and a whole lot of technology topics. I'm your host, Eric Cho. Today on the show, we'll be welcome Adam from Network to Code to talk about testing in network automation. I think this is a very important topic that is often overlooked, especially when you're just getting started out with network automation. For example, you don't really think about your code quality, your testing. Doesn't happen until later, but it is very important topic nonetheless. And I was really happy to read about Adam's three-part blog post on this specific topic. So very happy and excited to welcome Adam to the show. So Adam, how are you?
Thanks, Eric. I'm doing really well. I'm glad you enjoyed the blog post. I totally agree with you that it's something that's overlooked a lot, and that's kind of what led me to make those blog posts um, to help
Yeah.
beginners, kind of, I guess.
Yeah, I think it's also a very wide topic, right? Like, I mean, there are actually positions within companies that are test engineers. So therefore, a lot of times you talk about testing, and you could be having a conversation with somebody for 10 minutes, and you're actually talking about different kind of testing.
Yeah, and just the number of stages that testing is implemented in is just astounding. Like, regression testing, unit testing, integration testing, like system testing. It just goes on and on. And the more you learn, as with many things, the more you learn you don't know, because you just keep snowballing into more and more subjects.
Yeah, for sure. So that was in reference to actually sometimes I feel people. Anyways, like let's table that, because I am very excited to dive into the topic, but I always want to start with your origin story, your background, and how did you get into networking and technology and all of that. So Adam, before we dive into PyTest, Python testing, can you tell us a little bit about yourself? How did you get into technology, and your origin story, basically?
Yeah, um, I'll start talking about, I guess, how I got into networking. Like
Sure.
like many people, I I wasn't a network automation engineer. That wasn't my first job. I was just a regular network engineer,
Hmm.
um, and I was probably about 19. And my uncle worked for Cisco for like 22 years.
Oh my
Um,
God! Wow.
yeah, he was there from like the 80s to 2000 or something like that. Um,
He was there when the bridge was just red.
yeah, he was. And I have like, he gave me a Cisco Letterman jacket that he got for his
Yeah,
like 10-year anniversary, but it was really cool. Anyway,
yeah,
um, I was kind of deciding, what I wanted to do post high
sure,
school. He was like,
sure.
you should go get your CCNA,
Hmm.
and venture into that. I was like, I don't know. Um, but I did. So I did. So I got
Oh
my
wow.
CCNA.
Yeah,
And then, from there, I started getting into and, help desk was kind of my first job.
yeah,
And then from there, you kind of talk with some network engineers like, oh, can I look over your shoulder while you do this configuration or add a route or whatever?
yeah.
Um, so I did that for a while. And then I actually got uh, it's like a tier one network position for Whole Foods
Hmm.
um, in Denver, Colorado, and
Yeah,
I was there for a few years, and I wanted to increase my networking knowledge, so
sure.
I studied up for a CCNP and got that CCNP. And while I was there, I actually finished my undergrad in computer science
Hmm.
because I wanted to be a software developer. I thought this networking stuff wouldn't last, I guess. I was like, this is cool, like, but I want to be the cool guy
Yeah.
making video games or the next Excel or I don't know something. But
Did you tell to your uncle this networking thing is not going anywhere? This internet fad is
yeah,
just gonna fade really soon.
yeah, this isn't gonna go anywhere. But
Exactly.
it did, and I kept getting better jobs. And then um, after Whole Foods, I actually moved to where I live now. I live in Tulsa, Oklahoma, so I'm in the
Okay.
Midwest. And I got a job for one of the Indian nations here. We have
Hmm.
we have the reservation land and stuff.
Right.
And for one of their casinos here, and it's a pretty small shop. There's only 5 network engineers,
Sure.
but from there, uh, I was because there were so few of us. We
Yeah.
touched everything. I touched WLCs, I touched MDSs in the data center, I
Yeah.
touched Nexus 9Ks, 2950s, and access switches, just everything, like
Yeah.
Cisco ICE, ASAs, and I was there for 4.5 years, and that's where I really learned, I guess, about everything Cisco had to offer, a very Cisco shop.
Right.
Um,
Right.
but
No,
somewhere
I'm
in
kind of,
there,
yeah.
I was just going to say, somewhere in there, maybe 2.5 years in, it was probably 2017, early 2017. Um, there's a company here called Quick Trip, QT. It's a
Okay.
gas station company, but Network to Code actually had a contract with QT, and QT had a lunch and learn about their automation journey with
Hmm.
Network to Code up to that point, what they were planning to do, how they were doing it. I went to that and
Yeah.
was like, I can combine, some programming I've learned with this networking stuff, and
Yeah.
spent the next 3 years just playing with stuff. Every chance I got at my job, automate everything from like updating IP phones to updating VLANs to anything I could try and automate. I did,
Right.
and that was kind of where that journey started.
That's nice.
Now I'm here.
Nice. Nice. Yeah. So, I don't know. Our family donates buckets of money to Whole Foods every week. So, so it's nice to see. So it's nice to see we contribute a little bit to your
Yeah,
college education.
you did.
Where we hand the money to. That's like a black hole to us. Now I know it's Amazon, but
Yeah,
you
now it's
know,
Amazon. Not my day. It was just Whole Foods.
yeah, yeah. No, but it's interesting. You also mentioned the resorts, right? The casino reserve resorts.
Yeah.
Because back when I was in Palm Desert, so of course there's like a huge um, casino and Indian reserves over there. In fact, you couldn't get by you couldn't get to the desert cities without crossing a large chunk of the reserve land.
Oh, wow.
So we had to deal with that. But it's interesting you mentioned Cisco because for their network, because I talked to their network admin a lot too, back when I was working for the ISP, and we had to give them fiber access and all of that. It's a very closed loop system, right? So like it's never connected to the internet. I wonder why. No, no, but it's
Yeah.
closed loop, right? And then they're doing odds and all the slot machines or whatnot. They monitoring, very stat driven. So I was kind of surprised that you mentioned they were a Cisco shop, but I guess it's like the software wise is closed loop, but the transport is just
Yeah.
data pipes, right?
Yeah. And to speak to that, like everything everything we got, any appliances we stood up, was on-prem. It was always
Yeah,
on-prem. Um,
right. That's what I heard
because
too.
yeah, you we couldn't use any, like, we used Cisco WebEx or Teams or whatever. It was WebEx, but
Yeah.
um, that was like the only cloud thing we used. We had a DNA Center instance on-prem.
Hmm.
Microsoft Exchange was on-prem. Like, it has to be on reservation land. So that's kind of why they have it that way. But it allows me to touch a lot of stuff, that might live in the cloud. Like, I can
Yeah.
I can stand up ICE in VMware now, I guess, if I needed to.
Right. Yeah. So I would say I would compare this to kind of the federal services. So, back in a lot of the cloud providers or even just service provider in general, they have a dedicated team that service the government and like the federal government because you have to have certain kind of clearance and certain kind of practices that are very unique to that vertical. And I would say it's even more restrictive in the the casino and gambling gaming space.
Mhm.
But it's cool, right? I mean, you've been there for like three years, so it's not a short time. It's definitely good exposure. It sounded like.
Yeah, it was really good, and helped me, um, and with the kind of integrating automation in that, it allowed me to do automation on other things other than just routers and switches and stuff. It allowed me to play with unified Cisco unified communication stuff and firewalls and even automating things in ICE and stuff like that, which was good, I think, for me.
Yeah, for sure. I mean, so before this podcast started, we actually went to a little bit about your college education, and you wanted to, and you also alluded to earlier that you wanted to be a programmer. But what, I guess, what besides just kind of the flow and life, I guess, but did you? I guess how did that impact your decisions later on regarding automation and how come you never went into application development or just a developer job full time in general?
Yeah. It might sound a little cheesy, but I really liked the idea that like I had the power to connect multiple systems, I guess.
Hmm.
You know, one computer system can only do so much by itself.
For sure.
And you need that connectivity. That's what really makes, computers work. So that idea behind the synergy of computers just really intrigued me. So I liked the networking stuff. I also liked that it was kind of a black box to a lot of people.
Hmm.
Um, even, I would even say I know software developers who are just like, yeah, I don't know. I just hope I have internet, when I plug this in. I don't know really what's going on behind the scenes.
Yeah.
So I really like knowing like how these routers get routing peers and what protocols are used. And I kind of liked having that knowledge.
Yeah. Yeah, for sure. Me too. So I got my first internship at an ISP, and I remember just thinking about you know, that's how it works.
Hmm.
That's just bubble gums and duct tapes, right? Like I'm
Yep.
surprised even like passing traffic, but there we are. We're selling it for money. And no, I hear you completely. I couldn't agree more, right? Like it's fun to going to really know about peering exchanges and
Yeah. It's just not, it's so many people take the internet for granted. You know, I like,
right.
I like to know what I'm using and kind of like how it's working. Even like everything from driving a car, like I'm not a mechanic, but
Hmm.
I'll watch YouTube videos about, an alternator in a car or how the engine components work just because I think it's good to know if you're using it every day.
Yeah, you never know when you will need it, right?
Yeah, you never know. And then you're knowledgeable when you need to talk about it, at least a little bit.
Right. Right. So like it's one of those things. Yeah, me too. So I remember the first time I wanted to buy my wife a wedding ring, I went in and I didn't know anything about it, and they were just talking about like clarity. I thought it was just a matter of size, right? It's really not about that. It's about the cut. It's about clarity. It's about like anyway. So I went home. I did like maybe 20 minutes of research, and it was back on Blue Niles too, and it was like 20 minutes of research. Next time I went in, I feel so much more like knowledgeable, and I feel like the BS level just went down by 50%.
That's the thing, right? Like it doesn't take that much time, but just get your foot in there about some subject and you're miles ahead, I think.
Right. Which is a nice gateway to talk about PyTest. So you mentioned, you're a networking guy, CLI, but you were thirst for knowledge. You really wanted to know how things work. But how does that translate into PyTest, testing, and Python?
Yeah. So uh, I fell victim to, sorry, there's an airplane going by. I fell
No worries.
victim to, the as someone who starts coming from a network engineer position to an automation engineer, um, and even computer science class I took, testing wasn't a really thing. Yeah, I had to take an elective on software development, and it was talked about,
Right.
but I never really implemented it. Computer science is all math. All I took was math. It feels like all I took was math. Um, but so when I first started, um, I didn't test anything. I knew it, but you just want to get stuff working. You put hours into understanding the syntax and how things work. You just want to see some kind of result. You don't.
Yeah.
You want to be able to, even if you're just changing the description on an interface. Um, couldn't tell you how many hours that took me to initially get, including research. You got to read about NetMiko and how these
Yeah.
things work, and then once you start reading about that, you start deep diving into like, oh, how's this working, and what happens when I send a list of commands and stuff like that. But
Yeah.
testing wasn't really a forethought in my mind, and it was only really once I got to network to code that was they were like, oh yeah, you you need this. Testing is part of developing software, and
Right.
that's I think the line between kind of someone who just scripts and someone
Mhm.
who actually makes automation suites for networking. At least one of the differentiators.
Yeah, I agree. I mean, and it's good to see that they're preaching good hygienes, right?
Yeah.
So I think you're right about initially. It's of course you want to get things to work. Right? What there's nothing to test if you don't have working code.
Hmm.
But once you first get that code working, you do have to start thinking about maintainability, testability. Well, not even testability, but just having other people to review your code and how can you be sure that it's working after the third generation or even a month later you come back to it and you're not really sure what you have done and then you make a change. um, then do you just pray and that everything
Right.
works? How can you statistically verify that it's working?
Yeah. And if anyone is like me, you write your code, but you're like, how do I know for sure that this is doing, like, there's some black magic in there. And how do I know that every time I run this, it's going to do that? That was a thought in
Right.
my head as I got introduced to testing and how how to think about it, I guess. You're just validating, yeah, it's going to work 99% of the time.
Yeah.
But it's assurance to have that test there. And it's just good hygiene, you know. Um, yeah.
Yeah, for sure. It also is also when you have external dependability, right? So a lot of times when we do write scripts or when we write our functions, we actually are talking to the switch, we're talking to the router or UCS, whatever APIs. When you have that dependability, it introduces variables, right? So how do you know that when something breaks, it's not you, it's the other guy, or vice versa, right? Like it is you, so
Hmm.
better go straighten up your function or whatnot. So those are all the different things that testing could give you.
Yeah. And I think to that point, in the fact that we do interact with switches and routers, they
Hmm.
don't natively send us, well, okay, now as automation develops, they do, but they don't natively send us structured data.
Right.
You query a 2950, you're not querying some awesome Nexus API. You're getting a text file of text back. Um,
Yeah.
and there's so many variations of what you could possibly get back.
Right.
Um, those tests you can account for that. I think that's
Yeah.
important.
And for sure. And as more and more abstraction that you're introducing, right? Because like you said, at the very, very low level, you're actually getting a text file and output back. And it's up to the program to terminate and watch for those keywords to say these are the outputs that you grab back. But they abstract that for you. So you do get structured data if you use something like Paramico or I'm sorry, NetMiko or
Hmm.
Napalm or whatever. But what if those modules don't work? What if you need to troubleshoot even lower than that?
Right.
So, but anyways, so those are the testing, like I guess the whys of why we need testing, and it seems like that's once you get to network to code, they preach good hygienes, and that was an area you start to dive into.
Hmm. And I think I just want to add one more reason that came to my mind,
Of
um,
course.
was the fact that we are so open source. When you have anyone, when anyone can contribute something, you need to verify. I guess you would call it regression testing. That any changes or anything they add doesn't break the functionality of what's already there. So that's another important one, and why for testing.
Yeah, for sure. So I think we should keep in mind like everybody who's listening to the podcast may have different familiarities and different levels of coding experience.
Mm.
So maybe we should dive into, so what is regression testing? Can you give us a 5,000 feet overview?
Yeah, so regression testing, at least the way I learned it and kind of view it, is
Sure.
it's there and it can be typically, what I see it as are unit tests,
Hmm.
which we can talk about unit tests, but they
Sure.
test functionality of the code um, post post change almost, and
Right.
they're run every time. Typically, they're running a CI pipeline
Sure.
to kind of check that validation that the code is still running. But
Yeah.
in short and sweet, it's there to test that your code still functions exactly how you thought it did, given any changes in the code. It's kind of how I
Yeah.
view it.
Yeah. Yeah, for sure. So when somebody for example, when I was working for Microsoft, typically when you release a software version, the first thing you do is just want to make sure you didn't break anything that was already existing.
Hmm.
So to me, that's my definition of testing, right? Like regression testing was just like you didn't break anything that was
Yeah,
working before, and if you had, you better go back and just see what broke.
figure out
Um,
why.
Exactly. And good tests would tell you would point you to the right direction, if not the precise point, right?
Yeah, I mean, adding tests in general is good hygiene, but adding effective tests and efficient tests is a whole nother iceberg. Like you can
That's
add
a new
tests.
whole
Yeah,
career path.
it really is. It's crazy.
Yeah. Yeah. I would say um until I started working for a software company like Microsoft, I didn't know there were actual career paths for project managers as well as test engineers, right? Like
Hmm.
you could actually go all the way up. So typically what I saw was in other companies I worked for, it was you get developers, so which is like engineering track, you get management track, and that was it, right? So you have your clear path toward, maybe to a principal engineer or to CEOs and VPs. So those are the two tracks. But when I get to Microsoft, at least back then, it was like, no, you can actually get to partners of being a PM. You can actually get to, very high level as a test engineer. So those were like the four verticals you could actually get to. And it's like a testament toward how deep you could get for testing.
Yeah, I would say it's more like it's prevalent in network automation, obviously, but
Sure.
the testing foundation comes from software development. That's where it started.
Yeah.
And I think as network automation becomes more standard
Yeah.
uh, and adopted, there will be positions purely for testing network automation suites.
Yeah, at least to a certain level, right? Because I do see the ecosystem evolving really fast, and part of it is, as you alluded to, was because software development has been doing this for a long time. So we're
Mhm.
kind of just taking some of the practices over, adapting into the networking contact, as you have done for your blog post. So, before we dive into PyTest, can you just tell us the difference between what you said before, unit test, integration testing, end-to-end testing, or system level testing? So what are the differences between those?
Yeah, so unit tests are testing a single point of functionality. Um,
Sure.
and my initial blog post, I think it's my first one. Um,
Hmm.
the example I pull was a function to standardize MAC addresses. Arista, Cisco can have different formats of MAC addresses. Uh,
Sure.
so you may write a function. You say your boss wanted a list of all the MAC addresses or something of all the switches at some site.
Sure.
Um, and he wanted them in the same format. You might need to write a function that takes input of all these different formatted MAC addresses and makes them into one. And the unit test in that case is ensuring that given expected input to that function, it produces the expected output. And that's a self-contained function. Typically, at least what I've seen, are unit tests tied to functions. Um,
Hmm.
that's kind of the way I thought of it as I first started getting into it.
Sure. So how is that different from, say, integration test? Oh, by the way, we're going to link all of the Adam's blog posts and all the resources that we talk about in this blog post. But if you're watching it over YouTube, you have the benefit of following along the blog post, as as what you know uh, Adam was Adam was referring to, like your function and so on. So unit tests for sure. So you're testing like a little piece of code and
Mhm.
or function or just scope wise is just code level. So how's that different from integration testing or system level testing?
Yeah, integration testing I see as testing two things that interact. In my head, an example of that would be like testing your MAC address function, but prior to that, testing that you're able to get the MAC address table from a switch.
Sure.
And you might write a test that tests those in conjunction or those integrated, and you have an integration test.
Hmm.
That's how I view it.
Right.
And
Yeah. So yeah, go ahead.
I think, and part of the reason I wrote the blog is to kind of to think of these tests in terms of networking because, like we mentioned earlier, these do come from software development, and I think
Hmm.
it's a little easier to think about it in software development world. An integration test might be you're testing, you have a web page or whatever, and you click a button, and it contacts the database and sends something back. Um, that's an integration test, and that's initially was easier for me to wrap my head around because you're like, oh yeah, it's different parts of a system that are integrated, and you're just making sure it works.
Yeah. Yeah, for sure, for sure. So, I would agree to that 100%. Is just your unit testing, and then the next, just you're kind of low level. So, I mean, we're network engineers, so you're almost looking at kind of layer one or two, right? So those are your low level blocks. You're looking at very specific point that you're testing for. Like, does this return the MAC address I'm looking for in a good format?
Hmm.
And then integration testing will be one level up where you're testing multiple components where maybe, like you said, a web API plus some switch. And so you're integrating. And then the end to end testing is where you're moving up even further. So it would be bunch of integration testing tied together and you're behaving almost like a user where you're just testing the feature end to end, make sure it doesn't nothing break. So that's my own thoughts and personal opinion on different levels. But your blog specifically, all three parts of that blog deals with kind of the ins and outs of the unit test portion, correct?
Correct. Um, that's I think the most prevalent, at least what I've had experience with. So that's kind of why the blogs cater to that.
Yeah. Yeah. So I think that's also why I wanted to point out is because it's always easier for me to compartmentalize when I'm trying to learn something new. So let's just say you're new to testing. If you're listening to this podcast, you're new to testing, and you hear all these tools about Batfish or ZooCQ or PyTest and unit test module and Python. All of these, so you kind of want to just compartmentalize. So the Batfish and ZooCQ of the world, they deal with higher levels of testing. I'll go ahead and include a link in the show notes where the two founders of Batfish and Suzy Q, Dinesh Dutt and Ratul, they actually wrote a blog post about this whole overview. So that's good to compartmentalize. So if you're listening to those tools, then that's that level. But what we're talking about here is really about like very detailed testing of specific code on unit tests, but in a network engineering context.
Hmm. Yeah, and I almost see Batfish and Suzy Q as if we were to kind of go back to our three testing categories, almost a system test because you're testing.
Yeah,
If you think of X number of network devices as a system,
right.
that's kind of what those are catering to.
Yeah, I agree. And you define what that system is, but it's a system
Yeah, right.
nonetheless, right?
Yeah, you
Multiple
do.
components. Yeah. You could be a data center or it could just be a rack of switches,
Right.
but nonetheless, it is interconnected. It is part of that system.
Mhm.
Yeah. So you mentioned, you specifically use PyTest for
Right.
your examples, right? So maybe just as a general overview, so there's three parts to your blogs series, right? So
Mhm.
can you just tell us what's kind of in the general overview, what the first part covers, what the second part is, and then what the third part is?
Um, do you have the first one pulled up? It was a
Yeah,
while
so
ago.
first one's right here. So I think you talked about, just
Oh
first of all,
yeah,
testing that function, and then fixtures. Go ahead.
yeah. So the idea behind the first one was to one introduce PyTest and kind of what
Hmm.
the idea of a test function looks like. Um,
Right.
and then on top of that, uh, there is the concept called of parameterizing something.
Sure.
Um, and I run over that in this blog post. And the idea behind parameterization is actually really cool. And
Yeah.
I didn't know this at first, so I was banging my head when I was trying to write a test, and I thought to myself, this function isn't always going to expect this input. Like, how do I test multiple inputs into the same function? And then,
You copy
my
and paste, of course, right?
my naive first was like, I copy this, I write it again, and just change the
Right.
input, and I'm done. Um,
Right.
but then you have like a 500 line test Python file that tests like two functions.
Right.
But yeah, I mean that's what I started, and then you learn about this parameterization, and
Right.
what this does is allows you to use a single test, but input different sets of data into that test. Uh,
Right.
and it's a really neat feature. And the best part about it is that the assert statements and what you're testing, um, as you loop through this data set, each test
Mhm.
is its own test. Um,
Right.
Another point I do make in the blog is that you could pass in a list of values to your test,
Hmm.
um, but when that single test fails on the second item in that list, it's just going to stop and fail. It's not going to test all the other ones after that because you're fundamentally just running one test, just with a list of data rather than one data. And I try and give those examples in that blog post because that really sets the foundation for why parameterization is so important and so widely used.
Yeah, it is a cool concept, right? And it's if you're just starting out in, I guess, coding, the parameters might be not as intuitive, but essentially it's you're doing 90% the same stuff, but you just want to switch out the input data, and that is what parameter gives you in a function. And so if you overlay that concept with testing, is your testing your test stays the same, but you want to feed in different types of data to make sure like they all behave correctly, without writing. Like if you want to feed in 50 values, you don't want to write 50 functions or copy and paste them. You just want to swap that out and over again.
Hmm. And just run them, uh, one after another really quick.
Yeah. And like you said, right, you want them to behave as individual tests. And that's what you alluded to
Yeah.
in your blog, is you want to run them as different tests as opposed to. So what's the difference between running a running all of them at the same time versus running individually as different tests?
Um, I guess, do you mean as when you run, like when you use parameterization versus when you don't?
Yeah, like when you don't use parameterization, you just feed in, a bunch of values, versus treating each of the value as an individual test, as far as like coverage reports or
Oh, okay, yeah,
like yeah.
yeah. So, um, when you just do one test with, you could send in a list of 50 items, but
Yep.
coverage is going to treat that as one test, and if that fails, if the first 49 items you pass in pass your test, but the 50th fails, like that whole test fails. Um,
Right.
as opposed to each individual test, cover would say, oh, you had 49 that worked and one that didn't.
Right. Yeah. So for example, if you're like your example was about testing MAC address formats, right? Like so
Mhm.
you normalize your MAC address and you want to make sure like all of the MAC addresses are formatted in a certain way, just because like if you think of your host, your MAC address is probably represented in hex, you know, column,
Colon,
hex, whatever, right?
yeah.
And versus it's like four hex columns. They're all a little different. Sometimes they're capitalized, they're not capitalized, and that's what your function does. to the example function does is to normalize into the same way. But you want to test out all these different scenarios that you encounter, to make sure, like, these values are feeding the same way, are turned out to normalize, actually indeed will normalize them.
Yeah, because I think in the blog post I might even put an example of a MAC address. Like, if you were to add something to parameterization and your function doesn't normalize that, like, it'll
Yeah,
tell you, and when you parameterize it, it's in a single test, and it tells you the exact value that it failed on.
yeah,
And it's just, rather than like, oh yeah, this whole test failed. So
right.
it's a really good. I think that's probably one of the more important blog posts. I mean, I only have 3, but
No, but imagine you have 300, right? So
yeah,
instead of telling you your code sucks, go fix it, go fix it. It's telling you, no, your code 90% is okay, but this
yeah,
value, like when you treat, I don't know, what's hacks go up to F, right? So G, if you have a G in there, then it's
yeah,
but anyways, yeah, it will tell you specifically where it's failing, but as opposed to just tell you, go look it up, it failed, but it will tell you where it failed.
yeah. And that kind of lends to what we said, where writing tests is good hygiene, but also writing good tests is efficient tests and informative tests. Uh, it's kind of the same train of thought when you write exception handling. You don't
Right.
want to just like, yeah, something went wrong. Sorry, I don't know what.
Right.
Good luck.
Yeah,
You want to at least
exactly.
try and send something back. Uh, so it's kind of the same idea with tests.
Yeah, I agree. It's more like an art than, I
It
mean,
really
writing
is.
good ones is really more like an art.
It really is, and I think that's probably one of the hardest parts of adopting writing tests. And I think one of the reasons why I put it off for so long is
Hmm.
it's not as simple as, like, I have this MAC address and I want it to look like this. Like, I know exactly my end goal.
Right.
I know what I need to do.
Right.
I can get on Stack Overflow and find how to manipulate a string in Python. And you're like,
Hmm.
all right, it works. When you think
Hmm.
about tests, you can't really Google, how to test a function you wrote. Like, you have to critically think about, how am I going to test this? Um, and that, in the beginning, that's really scary. It was very scary for me.
No, scary for me too. I
Yeah.
think I think that's what makes it a fantastic tester versus just somebody who's so, like, he or she is able to do stuff really elegantly, and you can't really judge that elegancy, especially in testing, because all at the end of the day you just get fail or pass,
Mhm.
right? But it's only when you understand it completely, like you said, that you could start appreciate the elegance of a good test, or elegance of a good test code. I don't
Yeah.
know.
Yeah. It's crazy stuff. It's an art for sure.
Yeah, which brings us to a good question. In the next question that I have is, you know, if we already have unit test module in Python, so
Mhm.
why do we need to use PyTest? So can you give us a reason why you pick PyTest over just standard library unit test?
Yeah. The main reason is,
Yeah,
when I started, learning unit tests and using the unit test library,
yeah,
is it was confusing for me. Um,
yeah,
there's a lot of boilerplate code. You have to have classes.
yeah,
Um, it's not as succinct as PyTest, or
yeah,
extensible, from what I found. Um,
yeah,
it's a lot cleaner, and you'll notice, like, in the blog post, when I have, like, to write a test function, you're more or less writing a Python function. Like, you don't necessarily need to understand how classes work, and
yeah.
inheriting, and you don't have to really deal with that. You're writing a Python test. And PyTest, while yes, it adds more abstraction,
Hmm.
um, I think it's easier to learn and follow.
Right.
And that
Yeah,
was
I
kind
would
of my
agree
full
with that.
split.
Yeah, definitely. I think a lot of people would start, or I don't know if a lot of people, but many people would start with Nose or unit tests, which are two other, like kind of testing libraries or frameworks to begin with. But they'll quickly find it not as intuitive. And I
Yeah.
think I would agree with you, like the learning curve is certainly higher, right? Just like it's almost like the difference between Java and Python, right? In order to just do a hello world in Java, you gotta like do a public or private class. You gotta do the
Yeah.
main function. You gotta call that main function. You gotta worry about these, curly brackets. And before you even start, you just got defeated, right?
Yeah.
You're just like,
That's the
what is
thing.
all this? Like,
And at least for me, it tells you, like you said in Java, you have to write all this stuff. Like, I want to know why I'm writing this stuff. So there goes another 10 hours, like reading about why I'm writing this class here and private versus static versus public. So uh, using the PyTest gets you immediately into testing, I think. A
yeah,
lot
and
less open.
also like you said, right, you want to understand why. So if you're using a class, you have to use it to do. So here's like kind of anatomy of a test function, right? And you will see this in Adam's blog post. So you would get, you would define something, and then you would get some kind of input, and then you will kind of compare that input, compare the results of that input when you feed it back in, and you would either do like an equal or not equal or something to determine the success or failure of that test, right? So those are the three kind of main parts of a test. And in unit tests, if you use class, you have to use like self dot assert, right?
Hmm.
Self dot equal, self dot, assert not equal, whatever. So if you're truly wanting to understand, then you have to go into like object oriented programming, why
Yeah.
you use a self versus not. So definitely that learning curve, as opposed to what you would see in Adam's blog post, just a bunch of functions, which is a little easier to understand.
Yeah, definitely. And one great thing of PyTest is that it also does support unit tests. If you find, if you're contributing to open source or whatever, PyTest can run unit test classes and files and that kind of stuff.
Right, right. So so we talked about parameters and in the testing function, and we talked about PyTest, which there's a lot more like advantages to PyTest, right? So I'll put the show notes in Brian Oken's test. It's called in Brian Oken's book. It's called Python Testing with PyTest. The second edition is coming out pretty quickly. I think in the next month or two, if they hold up to the January 2022. So we're recording this end of 2021. So that's a good starting point if you wanted to learn more about it. There's a lot more advantages to PyTest over some of the other libraries and framework, like integration with coverage, or you could have plugins. So if you're
Mhm.
specifically testing for like Django, for example,
Django is
right?
Django's one we use heavily because it's an Autobot. So
Yeah, for sure. So do you want to talk a little bit about like kind of PyTest and plugins, so what they are and what's the advantage?
I honestly haven't ventured too much into that,
Yeah,
because we have our Autobot core team here. Um,
sure.
I kind of, I've ran tests and kind of understand it, but I've never really developed my own, Django test or plugins for PyTest.
Yeah.
So I honestly
No,
can't
no
speak too
worries.
much to that.
Yeah, no problem. Like me neither, right? So all I know was, um, if you're reading PyTest, then there's a plugin for that. So automatic like pulling like PyTest dash Django or whatnot. So you install that plugin, and automatically it understands a lot of the native like Django based view controller or models and stuff like that. So it saves you a lot of work. But the point to take back is PyTest is extendable. Not that the other frameworks are not, but it's has a vibrant ecosystem, lots of plugins that you could just install, which ultimately saves you time and effort, right?
Yeah, and I think it helps also. I mean, like I said, I don't have a ton of experience, but when I do work on Autobot and run
Hmm.
tests, like if you look at the test files, if you understand Django, like because you have that wrapper, I guess, around objects in Django, your tests
Right.
are written in a way that look like Django. Like, you're testing Django object, and you're like, okay, that makes sense. And I don't know how it would be done without the plugin. It's probably more lines of code and not as clear,
Yeah.
but it gives that layer of abstraction, which helps people. That helps me read the test.
Yeah. Yeah, for sure. And that's just one example, right? So if you're using I don't know, Twisted, and so there's probably a plugin for that. So it's a lot closer aligned with like the formats and the
Yeah.
syntax and Twisted D, and other projects. So yeah, for sure. So like if even if I just look at, like PyTest, let me pull up that screen right here. Yeah. If I just pull up like PyTest, it's plugin, and you could see like there's the timeout, Pepe, flakes, and all of that. So it. I mean, we don't pick PyTest because of a popularity test. We pick it because it has a lot of ecosystem and plugins and that we could leverage.
hmm Um,
Yeah.
another really cool one that actually comes
Yeah.
to mind is we have a library called NetUtils, a network
Okay.
to code does, and it's basically it's a lightweight um, like utility library for network operations, like adding adding IP addresses together, getting the last host in a subnet range, stuff like that.
Hmm.
But we wanted to keep it really lightweight, so what we ended up doing is using doc test within PyTest.
Oh,
So
okay.
so you know, and this kind of lends itself to us having good hygiene. Is all our functions require doc strings that actually test the function of that test. And uh, one of the plugins of PyTest is that it runs that function in your doc string as the example, and if
Yeah.
it's not right, it's going to tell you. It's
Yeah.
kind of
So
cool.
for people who's not as familiar with doc test, can you just explain like just the overview of how that works?
Yeah, so uh, in a typical doc string, there's we use the Google format. There might be a more better proper name for that. I don't know, but
Sure.
you have docstring basically tells you about the function and its inputs and its outputs. So you have kind of a top section that I think is args, which are the arguments into your function. You
Hmm.
define them and what type you expect. And then you also have a section on that, which is return, which is what the function returns and what type and a little description about it. And
Yeah.
under that, you have an example section. And this is what that plugin looks at. And it's almost like a little lambda function. Is it just reads that, uh, runs it in the environment, and you pass in input in there and the output, and it just checks against what you're actually seeing in the doc string.
Yeah. Yeah. Yeah, so that's what's really cool about it, right? You kind of self-contain both testing and your code. Like you
Yeah,
included the expected output in your code,
yeah, it's
and PyTest just automatically pick that up.
yeah, it's like I mean we have unit tests in our own test suite, but uh,
Sure.
it's and I think that helps with being able to. Sometimes you can't find examples for these things. Um,
Right.
so it's nice you just look at the doc string, you're like, oh, okay, that makes sense.
Yeah, so that's like documentation on steroids, right? Like so
Yeah,
you're
it really
document
is. Yeah,
and you're running. Yeah,
running tests
for
on your
sure.
document examples. Yeah,
Correct.
yeah,
Correct.
that
So
just
this
came to
is your
mind.
expected output. That's your assert equal
Yeah,
within your
yeah,
documentation.
yeah,
Yeah. So we discussed, why we pick PyTest because of popularity, customization, integration, and then we talked about PyTest has a really cool feature on parameterizing. I guess that's a word.
yeah,
And and you cover that in the second part of your blog. And when you talk about like the third part of your blog series, you actually talk about mocking, right? So can you tell us what I guess along with mocking, can you tell us what like fixtures are, like Teardown, startup fixtures, and then what mocks are used for?
yeah. So tests, any test you run, the idea, especially in unit tests, there are some main points that I try and drive with unit tests. One, you want to make sure that your test is actually testing a single unit of something.
Right.
I think it's really easy to write a test, but it end up actually testing a few things. Like
Right.
you want to make sure it's testing one thing that you're doing.
Hmm.
And another point is you want unit tests to be fast. Um,
Right.
you don't want to sit there waiting minutes for your unit test to run. Uh, and so that kind of lends to fixtures. So what fixtures
Yep.
are, and kind of the setup teardown process is,
Yep.
you can define, I see it as defining kind of static data that you can pass to these functions.
Yep.
An example being, sometimes an example being, uh, I might be writing a plugin for an Autobot, and I'm expecting like JSON data from Autobot, right?
Right.
I don't want to spin up an instance of Autobot, run that, populate data in it, get that data out, and then pass it to like a testing function. Um,
Sure.
I can make a fixture that just returns that structured data that I would be expecting, um,
Hmm.
and that's it. It just returns that and holds that. And the great thing about fixtures is that they can be used anywhere. You define them somewhere, and they can be used in multiple tests. So if you needed that data for multiple tests in your test suite, you just have to define it once, and you're able to use that basically wherever you want.
Yeah. Yeah. No, that's I'm glad you brought that up, right? Because that's something that we should have covered before, but we did not, which was kind of the zen of testing.
Yeah,
Like, you want to always test just one thing. You want to have, like, that's does the name unit testing, right? Like, you
yeah.
want to test just one unit, and then you want to make it fast so that you could you scope them correctly, and then you run them fast so that you could run lots and lots of tests without spending a lot of time wasted on perhaps unnecessary stuff. So back to what that parameterization again is, you don't want just one test that fail. You want to run 50 tests, and specifically knowing which one failed, if any of them failed.
hmm Um, yeah, speed and unit test is a really big one. You always get the, I don't know if when I was in school and stuff, you get the people that, you would say your code's compiling. Like, why aren't you working? Oh, my code's compiling. And then I've seen other people say, yeah, it's running its test suite. I don't know, I can't do anything.
Yeah, yeah,
Uh,
yeah,
you know, you want to
yeah,
make
for
your
sure.
unit
It's,
test fast.
you throw that over the wall, and until it comes back,
Yeah,
you can't do anything about it. Yeah.
um,
So, yeah, go ahead.
but that's kind of what the fixtures do, is they allow
Yep.
you to pass data into your different test functions. And I use a fixture, I believe, in the second blog post. One of them, I do use a fixture.
Right.
Um, a very, very basic one, but the idea is that you can use it for anything. Um, and I think the setup teardown, I think, is from unit test. I think that's a unit test thing.
Okay.
But obviously it can be used in PyTest. And the idea of that is, um, these setup teardown functions can be used to set something up, uh, kind of like an environment for your tests. And the way I've seen it used is to instantiate like a dummy database,
Yeah.
or like integration testing. If you need to stand up a dummy database, you want
Right.
to set that. You don't want to set up a dummy database for every test. You want to set
Right.
it up once for your test suite and then tear it down after. Uh,
Yeah.
that's
So
the
in
most common I've seen that.
Right. So in, if you overlay like just concrete example, so what Adam is, it's the first one that you use the fixture. So essentially you have a non-normalized MAC address, and then you have a normalized expected MAC address, right? So you want to have those always available to every single test that you have. So your fixture was just, add
Just
a decorator in front of it, and then you always have them for the rest of your
mhm.
tests.
Yeah. Um, and those are very simple ones. Obviously, they just return a string. Uh,
Sure.
but yeah, the idea is there, and that's one thing that PyTest, one pro of PyTest. You put a decorator on it, and voila, it's a fixture, and you can use it anywhere. Um,
Yeah. Yeah. I
that's a really
mean,
cool part.
decorator is almost like magic, right? Like, you
Yeah,
put it in front of it, and voila, there it is. Um, yeah. And now it's like a API.
yeah, it's nuts. Some black magic there for sure.
Right. And mocking is like what Adam was talking about, was you're trying to fake like a transaction. So if you imagine, as he was saying, you're going out there, you're trying to get I don't know, like a Nexus device output back, right? But you don't always have a Nexus device. Imagine if you're running this test in a self-contained environment where you want to keep everything else constant, but your own code as the variable that you're testing, right? You can't always go out and get that Nexus uh, output back. What if it's down? What if it's not working? Or what if it's just flat out broken, has a new version, has nothing to do with what you're testing? So your mocking allows you to just fake that response to keep that consistent. So first it keeps it consistent, and also it keeps it fast, right? You don't always have to go out and make that API call.
That's definitely one huge pro, is making it fast. Yeah, mocking is a whole nother iceberg thing. It's not only can it be used, and I guess in the testing world, at least in the Python, you'll hear mocking and patching, and they're kind of the same. I guess the idea behind them is the same. You're faking something, but mocking, kind of like you said, you're mocking. I see it as mocking something like a call, or
a database, as you said,
database or something like that,
right?
And that just makes it so you don't have to rely on something real. You're just mocking that. Whereas
Right.
patching, at least the way I think of it, is that it's you're changing, you're mocking like a function or a class within your code. It's pretty confusing, honestly. The more you start reading about it, but and that's actually my idea for my part 4. Here we come.
Sure. Oh
Is
wow,
kind of the
nice.
magic mock, and how magic mock works in testing, because the number of things you can do when you mock a function or class is insane.
Okay. Nice.
Yeah.
Okay. Yeah. So no, I was just trying to read back, and I could have swear I saw that somewhere. It said this is the final part, but you're right.
I
It
think
didn't
so.
say part 3 was the final. So I'm gonna hold you up for it. Like
Yeah, I need to do
magic mocking.
magic
All right.
mocking. And that, when you do that, you can assert that functions, you can, I don't know if I did it in one of my blog posts, but you can mock returns from specific functions within a class, or you can check that that a function was ran X amount of times when you called something. It's honestly like the amount of things you can test when you mock a function or class within your code is insane.
Yeah. Yeah, for sure. Because it is a mature technology, is widely used. So that means it's solving all kinds of problems for people. So that means it's a lot of different branches and different edge cases that people already encounter, and they kind of integrate it back into the to the framework or library. So definitely there's a lot to it for sure.
Yeah.
So go ahead.
I was just gonna say, yeah, there's a, hopefully blog post 4 will help some when I get that out.
All right, I'm gonna hold you to it,
Yeah.
and I'll look forward to that part 4 and part 5 and 6, and
Yeah, just keep
whatever,
going, I
however long
guess.
that is exactly, until you have like a whole book worth, and you
Yeah.
just publish it. Nice. That's probably how Brian did his. He just
Probably.
started, yeah, just to start having all these examples. I go, well, somebody should just publish and look in the mirror, and that's what I did.
Yeah.
Um, but Adam, I mean, we talked a lot about why we use PyTest, and we throw all these like end-to-end testing, integration testing, and we talk about mocking, parameterization. So it sounded all very complicated, right? But I don't want to scare people in thinking testing needs to be this whole complicated thing. So how, in your opinion, how can people get, as network engineers, how can people get started with writing more tests for their code? Because like you said, it's good hygiene.
Right. I would think, well, one, with the help of PyTest, you don't need to know as much. We said it has a lower barrier of entry into there. So,
Right.
once you start learning a little bit of Python, you should be pretty soon looking towards PyTest. And
Hmm.
I think what I would say is think of little functions that are applicable in the network world. Um, MAC address is the one that always came to my head, but say
Right.
you wanted to, I don't know, change like a description on an interface. You might be able to write a test that takes in a dictionary of how Paramiko or something returns interface values and then spit it out and just make a test. The idea is, and I think with anything is you just, especially with testing, is you just need to do it.
Yeah.
When you first start, you're not testing for, uh, I'm just gonna think like the newest Halo because Halo came out like 2 days ago. But
Nice.
you're not writing a test that is going to be shipped out of Microsoft. You're getting familiar with it. Um,
Yeah.
so even if it's just write a test that your function adds two numbers together, uh,
Right.
that's a great one to start.
Yeah.
And then
In fact, I think that's one of the examples in the starter guide, right?
or, yeah, it is actually, yeah, the sum, like your sum function.
Yeah.
Um,
Yeah.
but definitely as network engineers, you want to try and think about how you would do that. Our PyNTC library
Yeah.
was really helpful for me as I learned more about PyTest. The coverage on that repository is pretty high,
Hmm.
and the tests are a little complicated. There's a lot of mocking,
Yeah.
but once you understand it, it really once you kind of know what's going on, you can look at that and see, oh yeah, like this is how testing something in the networking world looks like,
Right.
and that helps, I think.
Yeah, and I especially like the fact that you put this into the network engineering world, right? Because I think context do matter a whole lot here. It's like
Yes.
I could read 10,000 Python examples, but none of them deal with what I have to deal with on a daily basis: IP address, MAC address, interface description, BGP, that sort of stuff. But once you put those into the context, then it's relatable,
Yeah.
and you could see how you could help you.
Yeah, and that, when I was getting into it, I would Google PyTest, and like you said, everything's, make sure your sum function works, make sure your square function works, like that
Right.
doesn't like, okay, I kind of understand, but I want to, I'm a network engineer at core,
Right. Right.
I need better examples that help me. Um,
Yeah.
NetUtils, our other, maybe you can, put that link, is those
Sure.
tests are actually pretty simple.
Mhm.
Those would be great tests to look at and kind of understand because the functions are so simple. Um,
Yeah.
but yeah, the idea was to get it in the networking world because it's hard enough wrapping your head around it when the context doesn't even apply. Like it only adds more difficulty to that.
Right. You're like, "Hey, I have a calculator. I don't need to test that sum function. I know it works," right?
Yeah, like I can add,
Yeah,
I need something a
exactly. In
little
fact,
more.
my 80-year-old could add better than that, like, why am I spending hours, fiddling with the sum function? But no, you're right. So I think what I like, uh, two parts what I like about Adam's blocks and just NTC blocks in general. One is that it's put into network engineering context, and second is it scope it down enough so that it's understandable and relevant. So like you said, right, you don't have to be a programmer in order to get started with testing. So for example, in his first blog post, he has a what is it, 4 lines of code to define a function to normalize your MAC address, and then he has another 3 lines of code for that test function
Mhm.
to excluding your fixtures and all that, but another 3 lines. So for a total of 6 7 lines, that you're able to do tests, and those are the kind of getting started that we need, is putting into the correct context and make it simple enough to understand so that we could explore the new stuff, right? Which is PyTest. But we already know MAC address. We already know, Python functions, but we just need to learn PyTest that's relevant to us.
Yep, and that helped me um, kind of wrap my head around it. I guess another good one would be the IP addresses. Maybe changing a CIDR to an you know actual octet of values and testing that.
Right.
Something
Hey,
like
it's a good idea. So changing like slot notation, right? So a lot of times, even like I think it was Nexus or maybe it was iOS XE, like they use the slash notation, right? Slash 24, slash 27, 28 versus like a subnet mask with 255, 255, 248, whatever. So like, maybe we could, or not we, you, maybe you could write some, test functions and illustrate how PyTest could, validate that your function is working. But I'm not assigning more work to you. I'm just, brainstorming.
yeah. There's the more you think about it, you actually start realizing, wow, there's a lot of things I could actually test for. Because there's a lot of ambiguity in the networking, especially when you get like cross vendors. Uh,
Yeah.
yeah, maybe everything in even within Cisco, like Nexus versus iOS XR and all that stuff. So
Yeah, they're just they're a big umbrella called Cisco, but underneath it's like list individual little mushrooms, and they'll look
yeah,
very different.
yeah, it's kind of annoying at times, but that's okay.
You said it, I didn't. But no, I agree. Definitely. It's like yeah, and you're not even talking about like Meraki or
No,
UCS,
no,
right? Like we're just talking about routers and switches, and there's already much differentiation there. Um yeah, so Adam, we cover a whole bunch, PyTest, we cover about different levels of testing, kind of different fixtures, mocking. So is there any, call to action for you on just testing in general?
what do you mean? I guess.
Yeah, so like I think for people, we talk about getting started with testing. Is there any call to action, like how to get, once you get past that, do you want to direct people to, write their own test, or
Yeah,
is it just like you said, looking at more NTC libraries? So is there any um, call to action, like just get
I,
started testing?
I think, well, one, get started testing locally,
Sure.
um, and then, get stuff working. But the next best thing I think would be to try and actually make a contribution to one of our repositories. We
Okay.
have a ton of open source repositories.
Right. That's a
Um,
good call to action.
and making a PR, you're going to get, we're going to look at your code, and there's going to be people with way more experience in PyTest than myself looking
Sure.
at your code, and you'll learn. And I think that's a really, really good thing. And I even do that here,
Hmm.
we're big enough now that, I don't know every repository we have going
Yeah.
on, and someone else might be working on something. But if I
Right.
don't know that technology or want to better understand what that repository is doing, I'll try and add a feature or, refactor some code or something and make a PR because one, you have to understand what's going on.
Hmm.
Two, typically you have to write some kind of test for that as well.
Yeah.
So that would be, you know, probably the next best bet. And but obviously it doesn't have to be one of our open source. There's hundreds of open
Sure.
sources projects out there,
Sure.
and
Sure.
they all test. I can assure you, they all test. So
All right.
that
Don't
would be my
don't submit your PR without some tests, right? And then
yeah,
that's a good practice ground to actually bounce off ideas. So I think that's a another thing that it's intimidating for people to start with is making a PR, and like you said, having people look at your code,
hmm
but don't be right. Like that's another way to learn, and that's another way to just communicate. Is just pick out his brain, and you guys have a common thing to work at. I know I learned the most when I learned the most about Ansible when I finally submit my PR or modules to merge upstream, and writing that module was a very good learning experience to begin with, but talking to the maintainer, that was
yeah,
a even better way to kind of know their thought process, their structure. So don't worry about it, we're all in the same boat. So
mhm,
make a PR, maybe Adam will review your code, and
maybe
how he's a nice guy.
maybe, and that's the thing. You opening a PR, you're not going to break anything. You're not gonna
Yeah,
we're not gonna merge a PR that's broken.
right,
So
hopefully.
Hopefully, yeah. Okay, yeah.
Yeah.
Hopefully they will. I'm sure there have been
Yeah.
instances.
Make a different branch, and
Yeah,
then you're for sure you're not merging.
yeah.
Yeah.
But that's the
Yeah.
thing, you will learn, and it is intimidating. But 99% of the people that have reviewed my PRs are nice about it. They're not mean about it. They want you to learn, and they were in that same position at some point too. So
Yeah. Yeah, I will roger that for like just open source project in general, right? 99% of the time it's good. And for that 1%, the benefit far outweighs, that 1%.
yeah, it does. So yeah, that'd be my call to action, I guess. And I even do that here internally to repos
Yeah.
I don't know that I'm not personally working on, but I want to learn more about.
Nice. Nice. No, that's a good call to action. Sorry to put you on the spot. That was a
No,
nice
that's fine.
save.
Yeah, yeah, I think that's good. That's what I would do.
Okay. Cool. Hey, Adam, I had a great time chatting about testing. Like I said, I think it's one of the overlooked subject, but it's important to at least know about
Just
these different terms and stuff, right? So thanks for taking the time, and thanks for being on the show.
yeah, no, thank you for having me. It was a pleasure.
Yeah. So thanks for listening to Network Automation Nerds podcast today. Find us on Apple Podcasts, Google Podcasts, Spotify, and all the other podcast platforms. Until next time, bye bye. Bye, Adam.
Bye.